We already know about clustering of volatility. You know that large changes in prices tend to cluster together. And if you want to account for this fact in our presentation of volatility and its analysis, we can use some methods, and actually we already learned one. So in this example, when we used moving average, we actually accounted for the fact that volatility clusters. We choose the rolling window. So if we know that the most recent observation would be closer to the one that we observed yesterday in a previous trading session, that to one that happened some time ago, right? So if we observed a large change in prices today, most probably the similar situation was observed also in recent days. Also, prediction for the next trading session would be that our volatility would be higher, right, than in the past when we did not observe these large changes. So this is exactly what happened during pandemic crisis. And if we use rolling window for a presentation analysis of volatility, we account for this fact, right? We only choose a subset of our observation. For example, if in this case we present values based on recent 50 observation, this may give us more information that if otherwise we just calculate average, right? Take a look at the characteristic of our volatility. Average volatility for this our rolling window would be 20%, but the current volatility, and by the way, take a look at the function here. So we use VLOOKUP function to find a volatility for a maximum value in first column. And in first column we have dates, and the dates in Microsoft Excel, you may already know this. So Excel stores dates and times as a number, and this represents a number of days since the beginning of 20th century. So if you have a date like this, and if you are sure that this is a date format, if you change this to a general format, it should be 1. Sorry, this is 1990, but if we choose the beginning of our century, right, this would be 1. And each subsequent day has this integer value higher than 1. So if, for example, today, right, so it's 10th April, if you choose the date format into general format, this is 43,931 days since the beginning of the 20th century. So if you look up for maximum value, you will find the most recent date in this array, right? So we are looking for maximum value for most recent date, and this volatility is 53%, while on average is 20. So if you take a look at most recent observation, this 53% or 52% was much better estimation of future volatility than this average equal to 20%, while the maximum was 60%. Right, so this rolling window helps us to also predict future volatility with this simple moving average mechanism, because what is actually that we're doing is we're using simple moving average. And the other way, one of the example of how to account for these volatility clusters would be to use exponentially weighted moving average. Right, so in a simple moving average, our way to deal with volatility clusters was to choose only a subset of data. Right, we only focus on the most recent subset of our data. And exponentially weighted moving average, we will choose a different method. Right, so different method. And in this case, our mechanism to account incorporate this volatility cluster feature into our analysis would be to focus on weights, right? Because generally in our calculation of volatility, and also if we only focus on a subset of information, we use weights that are equal to, by definition, 1 over n. Right, so this is an weight for each difference between recent observation and average. So if, for example, I want to analyze 500 trading sessions, so about 2 years, if I want to calculate volatility, I would have weight equal to 1 over total number of observations. And this weight would be equal. So if I calculate volatility, this weight would be equal. If I choose a subset of observation, like for example 100, I just need to multiply it by 2. So if I have 100 observation, then each weight would be equal to 1%. And in exponentially weighted moving average, I will use this exponential smoothing for calculation of weights used in calculation of volatility. Right, so the weights will change, and in order to use exponentially weighted moving average, you basically need to choose this lambda parameter. Right, so this is the weight that is given to most recent observation. Actually 1 minus lambda is the weight given to most recent observation. So if this is our volatility, then the best estimate of the future volatility for the end day, or also the best presentation of volatility for most recent observation, would be to use previous one times our lambda parameter plus 1 minus lambda times, in this case, this is our rate of return squared to the second power. So we use most recent rate of return from a financial market. We use 1 minus lambda as a weight, and then we add lambda parameter times the previous observation. So first, let's take a look how weights would look like for some desired lambda parameter. I show you 2 examples, the first with 0.94 and the second with 0.99. Right, so if I have 500 observation in an order when this 0 is current value, so the most recent that I have, while the 500 is the last observation I have. So if I want to calculate weights for 0.95 lambda, the first weight would be equal to 1 minus lambda, so this would be equal to 6%, right? So 1 minus lambda. And weight for a previous observation would be just equal to 0 to this observation times lambda parameter. Right, and if I go up, this would be my weights. Of course, as you may already see, the better way to calculate the weights would be just to use the formula. So if I know that the first weight is 1 minus lambda and each subsequent is the newest observation times lambda coefficient, hence I can use this general formula. So I will use 1 minus lambda parameter here times again lambda parameter and raise it to the power where I have number of observation here, right? So if I raise it to the power equal to 0, then this would be equal to 1. So our first observation would be just 1 minus lambda coefficient. Okay, let's calculate the weights, and this is how our weights looks like, right? So this would be our simple average when I use the same weight for each observation. And exponentially weighted moving average, I'm using more of a most recent observation, right? And of course for lambda 0.99, it means that the most recent observation would account for 1%. So we can just copy the formula and paste it here and be sure that we choose lambda here and number of observation here. Okay, so this is how it would look like for lambda 99%. This would be lambda 94%, and these are our equal weights. So it's important to understand how these weights are constructed, but of course in practice you just need to focus on incorporating the data from financial markets right into this algorithm. What I do have here is I have rate of returns from euro to PLN from some time period, and I already have calculated simple moving average for a daily volatility using a rolling window of 50 observation. This is my chart, right? So we already know this method, just a rolling window of 50 observation for a standard deviation of this rate. Now let's do an example with exponentially weighted moving average. So if I want to start with the last observation I have, I need to have some assumption of what this observation would be. One of the approach would be just to calculate standard deviation and start with this value. So take a look. If I know that my formula helps me to calculate for end observation, I need end minus 1 in my formula. If I start with the last observation, I need to make some assumption of what do I start with, what was the previous. So in practice, what you do is you need some rational standard deviation. You can use some subgroup from this observation. You can use the global, right? So we can either use this 0.52 or we can start with 0.3. It's not that important. What is important is that the next observation would be equal to what? If this is a formula for variance, and you want to present standard deviation, you can start with the standard deviation and now use, let's say, lambda 0.99. So it would be equal to 0.99 times, right? So I have lambda times the previous observation raise it to the second power because this is my standard deviation and I'm calculating square roots, so this has to be variance, right? this has to be variance. So I'm using most recent observation plus, and now 1 minus lambda, so 1 minus this value times, and what do I have here is the most recent rate of return raised to the second power, which is actually this like volatility for a day, with assumption that on average is sufficiently close to 0, right? And then you just need to close the bracket, and that's it, right? So if I started with 0.50, I can now move down, right, and double click if I have observation to my left, and this is how it looks like, right? So this red would be simple moving average for 50 observation. This blue line would be exponentially weighted moving average for 0.99 lambda. Let's also calculate for 0.94. It's of course very similar, but now the only thing that changes is you can copy the formula, you can paste it here, right? And the only thing that changes is 0.94 here. So you can double click, and this would be 0.94. Sorry, let's start here. It didn't look quite what I've expected. So this would be our exponentially weighted moving average for volatility of daily, for daily volatility of rate of returns of euro versus PLN currency price.